Okay, in this problem, we have blocks connected by a string and blocks in contact with each other at the same time. All right, it says that the masses are, this has a mass of 1 kilogram, this has a mass of 2. So I guess this must be a lot more dense than this one. And this one has a mass of 4. And it is being pulled with a force of, we'll call it an FA, of 34 newtons. Okay, so determine the acceleration of the system. Let's check and see if we have friction. It says that it's frictionless. So, all right, so we can jump right in here. And that's going to be F net equals M net times A. So we're pulling with 34 on a mass of, it looks like 7, a total mass of 7. And so the acceleration of every piece in the system is going to be 4.86 meters per second squared. All right, so we're going to store that. All right, the next question, determine the tension in the cord. Determine the tension in the string. So we've learned that when we have to find the tension in the string, that we have to draw a free body diagram of each individual box, or an individual box. And so I really could do the 4 or the 1. The problem with the 1 is there's going to be an unknown force in the story because the 2 pushes on the 1 and the 1 pushes on the 2, and I don't know that. So for that reason, I'm not going to pick this part of the string. I'm going to pick this because I know this over here. So I'm going to come down here, and I'm going to draw my 4 box. I'm going to kind of turn it into a dot. And again, we have FW and FN that are not so important right now. And I'm expecting the system to go this way, so I'm going to make this F a long arrow. And I see coming off the other way is a little bit of string, so we'll do a little bit of FT. And so F net equals MA, that's going to be 34 minus FT. Equals the mass of this block is 4 and the acceleration is 4.86, and so we can find the tension in the string, which I got 14.56. All right, so I'm going to put that back in my picture up here. FT equals 14.56, and now I'm going to try to tackle and figure out the force that is exerted between the 1 and the 2 block here. So I'm going to draw a free body diagram of, I think, the 1 block. I'm going to pick the 1 block because I know some things about the 1 block. All right, so it has some FW, it has some FN that I don't care about so much. But I see I have some string going this way and the whole system's going this way, so that string arrow has to be the longer arrow. So we're going to call that FT, and since it's the same piece of string as before, it's 14.56. But I can see that the 2 block pushes on the 1 with a force to the left. So I'm going to draw a force to the left. I'm going to draw it shorter. And I'm going to call this the force of the 2 on the 1. And so again, F net equals MA. The bigger force is going to be 14.56 minus the force of the 2 on the 1 equals M. The mass of that block is 1 and the acceleration is 4.86. So the force of the 2 on the 1, I get a 9.7 newtons. So I'll circle that. But then I'm going to go back and I'm going to put that in my picture up here. The 2 on the 1 is 9.7. And so that tells me that the 1 pushes back on the 2 also at 9.7. And that's part C that they asked us to calculate there. All right, so hopefully that makes a little bit more sense for you. And we'll stop here.